We've talked about how to find the vector product by finding first the magnitude of the vector product and then the direction of the vector or cross product. Sometimes it can be helpful just to know what is the math? How does the math work? And then that way to check, or if there's something that you're unsure about, sometimes it can be helpful just to grab hold of the math, take a deep breath, and then hope that the math pulls you through to the other side. So if I have some vector A that I can write as A of x in the x direction plus A of y in the y direction plus A of z in the z direction, and I have some vector B that I can write in the same way, B of x in the x direction plus B of y in the y direction plus B of z in the z direction, skipping over at this point why this works, or how this particular form of taking the cross product is defined and constructed. You can find the vector A cross B by setting this up as a matrix. And if you haven't worked with matrices, don't worry about it. I'm doing this to show you where the final number comes from, where that final answer comes from. Not to make you have to do this over and over yourself. So if I put in, let's see, x, y, and z, and then ax, ay, az, and then bx, by, bz. Then, to find this in component form, we find the result for each component. So, the x component of this matrix is found by removing the row that's got our indices on it, the column that's got x in it, and taking the product, cross product of those two matrix elements. So I'd have ay times bz minus az by and that is our x component. There's a negative sign because of math I'm skipping over right here for the j component, but that would give us, actually I'll take the negative sign out and we'll get az bx minus ax bz in y plus ax by minus ay bx in z. And so if you simply follow that path and use this equation, then if you're given those two vectors in vector component form, you can solve for the cross product without having to go, okay, what's the magnitude of A? Then what's the magnitude of B? Then what's the angle between them? You do not have to do those. You can go through those intervening steps. And as a matter of fact, just want to check to see that I have room. Sure. Suppose I've got vector A, which is equal to 4 meters in the x direction plus negative 2 meters in the y direction plus 2 meters in the z direction, and I have some vector b is equal to 1 meter in the x direction, 3 meters in the y direction, and minus 4 meters in the z direction. And I ask the question, what is the angle between those vectors? Now, if I were just to give you two-dimensional vectors and say, what's the angle between them? You might not need to think of anything clever. You might just be able to break this down and say, okay, this is the angle with like the x-axis. This is the angle with b in the x-axis. Hey, what's the angle between them? In a very straightforward brute force sort of way. In this case, it's three-dimensional. So how do you do that? Well, I know that if I want to find the vector a cross b, that's equal to ay times, ay negative 2 times bz negative 4, or 8 meters squared, minus az by, so minus 6 meters squared in x, plus, and in the same way, that's 2 minus negative 16, or 18 meters squared in j, and 12 minus negative 2, 14 meters squared in k. I can look at this and I can see that, I remembered incorrectly where my calculator was, but after I see that, I can take the vector A and I can find that the magnitude of the vector A is equal to, let's see, let's call it 4.899 meters. Always keep an additional significant figure when you're working in the middle of a problem. If you cut to proper significant figures midway through a problem, then you're likely to make rounding mistakes. Then the magnitude of b is the square root of 1 plus 9 plus 16. So, 5.099 meters. And the magnitude of A cross B then is equal to, 8 minus 6. Or let's see, 2 squared plus 18 squared plus 14 squared is 22.891. And because the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times the sine of the angle between them, the sine of the angle between them is equal to that 22.891 divided by 4.899. 0.899 divided by 5.099, or 0.916. That's a unitless number, giving us the result that beta is 66.4 degrees. Hopefully a helpful example to show you some of the reasons why we're doing this.